Okay, so here I have an example that I got off the web, right? I just looked up, law of detachment, practice problems, and here it says use the law of detachment to draw a conclusion. So the purpose of this video is for you to see how do I solve a problem like this, and I try to think out loud so you can get an idea of what it is I am doing, because a lot of times when when you solve math problems, it's not supposed to look clean, I do have a lot of experience, but what I'm going to do is I'm going to attempt to do it as if I didn't know much about it. So these are things that you should be doing as well. So that's what I want you to get out of this video is basically try to mimic what I am doing, because this is the only way you're going to get good at solving math problems is you have to think. You got to use what we call metacognition, which is, you got to think about thinking. And that's a very important skill. All right, so you just got to know what kind of questions to ask yourself. Alright, so here it says use the law of detachment to draw a conclusion. Okay, so law of detachment, I already know that I have to start thinking about that. What is the law of detachment? Alright, but before I even get into that, I'm just going to read first this problem. So it says, if a student gets an A on a final exam, then the student will pass the course. And then they also told me that the student gets an A on a final exam. So law of detachment to draw a conclusion. So the law of detachment, so you really have to do know the law of detachment, and in my experience, using the notation really does help you understand how to come up with an answer. So for law of detachment, what I recall is I have some conditional statement, and if that conditional statement is a true statement, so I have a true statement for that, and then I also know that P is a true hypothesis, right? In other words, I'm told that the hypothesis is true, then I can conclude this, and these three dots just means therefore, right? So if this is true and this is true, therefore I can say with 100% confidence that Q must be true. And if I happen to forget, why this works, well, if I had a quick truth table, if I had true and true, true and false, false and true, false and false, right, in terms of P and Q, and then I made a conditional out of those two, I can see that when you have a true hypothesis and a true conclusion, well, in this case, that's going to be true. When a conclusion is false and a hypothesis is true, I know that the conditional statement is false. If my hypothesis is false and my conclusion is true, that will be true. And if my hypothesis is false and my conclusion is false, then I know that the overall conditional statement is true. So I can see the law of detachment was that if I know that the conditional statement is true, which I can see is this case, and in this case, and in this case, right, the truth value of the conditional statement is true, and then I'm also told that P is true, well, if the overall conditional is true, there's only three cases, and if I'm also told that P is true, well, I know that P is not true here or here. Well, since the overall conditional statement is true, and P is told to me that it is true, then I know for a fact Q has to be true. So that's the law of detachment. And this piece right here, if you look at it in terms of this, if you can remember the law of detachment is this setup here, that will definitely help you out in solving this problem. So let me go over here now, and what I'm going to do next is, since the symbols help me out, I'm going to convert all these into symbols too to see what's going on. So here I have a student gets an A on a final exam. That will be the hypothesis, which is P. Then the student will pass the course. So I know that's my conclusion. And now I have a new sentence here. It says the student gets an A on the final exam. Well, what does that go with? Is that the hypothesis or the conclusion? Well, the student gets an A on the final exam. I can see that student gets an A on the final exam. Well, that's just this. That's my hypothesis. So what they're telling me is this is true. The hypothesis is true, right? They're telling me the student gets an A on the final exam. So since I know this is true, well, I'm going to change all this into notation. I have a conditional statement where P implies Q. That's my first conditional statement. Then I'm told that P is true. So based on this setup, does that match up with the setup here for law of detachment? Well, yep, it does, because since I know the student gets an A, then I know for a fact that Q has to be true. So what is my conclusion? Because they said use the law of detachment to draw a conclusion. Well, my conclusion is Q. And what is Q? Well, Q is the student will pass the course. So my conclusion would be the student will pass the course. So that's the law of detachment. You can see converting it to symbols definitely helps out to see a little bit clearer. So as long as this, when you label everything and you can see it matches up, then we know that we can make a conclusion that if this is true and this is true, well, then this has to be true. And then Q was represented by the student will pass the course.